In the previous video, we examined how our optimal choice is affected when the outside world presents us with a change. This changes was, in the previous video, technological progress. But the outside world is full of changes, and all of them potentially affect the predictions of our models. In this video, we'll study how two important factors affect our choice. Those factors are income and prices. How do we study the impact of a change in income? So, suppose we have a consumer who cares about free time and consumption. This is what enters her utility function. She can have anything between 8 and 24 hours of leisure. Her free time is on the horizontal axis. And note that she has 24 hours of free time. If she has 24 hours of free time, she would not earn any money for consumption. And if she works 16 hours and has a leisure of 8 hours only, she would earn $240. So potentially, if she works for 16 hours and earns $240, she can exchange those $240 for consumption. So it turns out any consumption between $0 and $240 is feasible, and any free time between 8 and 24 hours is also feasible. The line separating the feasible set from the unattainable combinations of free time and consumption is what we call the budget constraint. The budget constraint is telling you the maximum level of consumption you can get for each level of leisure that you have, or that you can potentially have. Note, however, that just like any budget constraint, the budget constraint here has a slope. Do you remember how we called the slope of the feasible set before? Right? We called it the marginal rate of transformation. So this is the rate at which you need to give up one good to get a unit of the other. In this case, if she works one more hour, she gives up 1 hour of leisure in exchange for an opportunity to consume more. How much more exactly? Well, if you sell 1 more hour of your free time, what do you get in return? That's right. You get an hourly wage. So the slope of the budget constraint, that is, the marginal rate of transformation of hours of free time into money, is your hourly wage. In this case, it's a linear function because every additional hour of work adds exactly the same amount of money to your feasible options. This means that the budget line increases, or decreases if you wish, at exactly the same rate all along. Then it stays linear. What is the best that the consumer can do, given her linear budget constraint and her preferences? Let's lay her preferences over the budget line to see the highest possible indifference curve. When we do that, point A appears as the only point which satisfies two conditions. First, it is feasible, and second, it maximizes utility. Point A then corresponds to 18 hours of free time and $90 of consumption per day. Now, let's add a bit of income. When we give the consumer a bit of income, some money, no matter what, it turns out that her budget constraint has shifted outwards. This is because she can consume more even if she doesn't work. Notice what happens at 24 hours of free time. she can still consume $50 of goods and services. So the rightmost point of her budget constraint has moved up by $50. At the same time, if she works 16 hours per day and has only 8 hours of free time, what happens? She can have an extra $50 as well. So the leftmost point in her budget constraint has also shifted up by $50. As all her consumption opportunities have expanded by $50 for each hour of free time, her entire budget constraint has moved up and parallel to the old one. But notice that now her old optimal point A is no longer optimal. This means she can hop on an entirely new indifference curve and be happier than before. She's happier because she can have both an extra hour of free time and some more money to spend. This is great, isn't it? So, depending on the shape of her preferences, she can also choose to work exactly the same hours as before, but have the entire $50 extra added to her income. She could also end up working more than before and enjoy less free time. This will entirely depend on the shape of her preferences. Okay, so much for the income changes. What will happen to her choices if the price of her time changes? Let's go back for a minute to her old budget constraint. Her old feasibility constraint, if you wish. So, what did it tell you? If you laze for 24 hours a day, you will get zero, no matter what your hourly wage is. If you work 16 hours, however, and your free time is only 8 hours, then you'll be able to afford to buy goods and services equal to the amount of those 16 hours times the $15 per hour, which makes $240 worth of consumption. But what if your wage increases to 25? Will your income change if you don't work at all? No. It doesn't matter if you earn $1 per hour or 15 or 25 dollars per hour. If you work 0 hours, your consumption will still be zero. However, notice that each additional hour of work adds more than before to your income. So go from right to the left on the graph. Rather than 15, the first hour of work adds 25 to your income. The second adds an extra 25 rather than just an extra 15, and so on and so on. So in 2 hours of work, you get 50 rather than the old 30. In those same 16 hours, you could potentially earn $240 before. Now you can potentially earn a lot more, $400 to be precise. That's why the maximum point for 16 hours of work and 8 hours of free time has also moved up by 16 times the difference between 15 and 25, which is 10. And the total difference is $160. As a result of a change in the price of labor, a wage increase from 15 to 24 to $25 per hour, your feasibility constraint has massively changed. Combinations of free time and consumption, which were unattainable before, suddenly become part of your feasibility set. This means something you have craved before as unattainable may not even be desirable now. And all this because a single price has changed. So how will the change in this price affect your optimal choice of leisure and consumption? Well, point A is no longer optimal, so you go for the highest possible indifference curve given your new constraint. This is point D. Note that because point D is an equilibrium point, the slope of the budget line, that is the marginal rate of transformation of leisure into consumption, is also equal to the marginal rate of substitution of leisure into consumption. In other words, what is physically possible is the same as what is desirable. As a result, the consumer does not have incentive to move away from this point. And this is exactly how we know she's in equilibrium. What we've seen so far is how income and price changes may affect optimal behavior. But we're curious people. We want to know more than that. We want to know which part of this increase is due to the increase in income and which part is due to the increase in prices. This is what we'll come to know in the next video. Thanks. Keep watching.